In this video, we will discuss confidence intervals for proportions. A USA Today feature stated that 12% of the pleasure boats in the US were named Serenity. The parameter 12% is called a proportion. A proportion represents a part of a whole or a probability and can be expressed as a fraction, decimal, or percentage. Here are some symbols that we use in proportion notation. P is the population proportion. P with this little caret symbol over it is the sample proportion, and we read that as P hat. For sample proportion, P hat is equal to X over N, and Q hat is N minus X over N. We can also say that Q hat is equal to 1 minus P hat. For example, in a study, 200 people were asked if they were satisfied with their jobs or professions. 162 said they were. In this case, X equals 162, N equals 200, and P hat is equal to 162 over 200, or 0.81. We can say that for this sample, 81% of those surveyed were satisfied with their jobs. The proportion of people who did not respond favorably constituted Q hat, where Q hat equals N minus X over N. For this survey, Q hat equals 200 minus 162 over 200, which is 38 over 200, or 0.19, 19%. When P hat and Q hat are given in decimals or fractions, P hat plus Q hat equals 1. When they are given as percentages, P hat plus Q hat equals 100%. It follows that Q hat equals 1 minus P hat, and P hat equals 1 minus Q hat, when P hat and Q hat are in decimal or fraction form. Similarly, for populations, P plus Q equals 1, P equals 1 minus Q, and Q equals 1 minus P. But we won't do much with proportions of populations in this class. For example, a random sample of 150 assault victims in a large city found that 45 took no self-protection actions against the criminal. Find P hat and Q hat, where P hat is the proportion of victims who took no self-protection action. Solution: in this case, X is 45 and N is 150. So P hat equals X over N, which is 45 over 150, or 0.30, which is equal to 30%. Then Q hat is N minus X over N, which is 150 minus 45 over 150, which is 105 over 150, or 70%. Likewise, we can write this as Q hat equals 1 minus P hat. That's 1 minus 0.30, which is 0.70, or 70%. As with means, given the sample proportion, we try to estimate the population proportion. Point and internal estimates can be made by using the sample proportion. To construct a confidence interval about a proportion, you must use the margin of error, E equals Z sub alpha over 2 times the square root of P hat times Q hat over N. Confidence intervals about proportions must meet the criteria that N times P hat is greater than or equal to 5 and N times Q hat is greater than or equal to 5. The formula for a specific confidence interval for a proportion: P hat minus Z sub alpha over 2 times the square root of P hat times Q hat over N is less than P, which is less than P hat plus Z sub alpha over 2 times the square root of P hat times Q hat over N, when N times P hat and N times Q hat are each greater than or equal to 5. Assumptions for finding a confidence interval for a population proportion. First, the sample is a random sample, and second, the conditions for a binomial experiment are satisfied. To remind yourself of those conditions, see Chapter 5. Round the confidence interval for a proportion to 3 decimal places. For example, a survey of 1,404 respondents found that 323 students paid for their education by student loans. Find the 90% confidence interval of the true proportion of students who paid for their education by college loans. First, we calculate p hat and q hat. P hat is equal to x over n, which is 323 over 1,404, which is 0.23 or 23%, but we're going to keep it in that decimal form. Q hat is 1 minus p hat, so that's 0.77. Next, we determine the critical values. Alpha is 1 minus 0.90 or 0.10. So alpha over 2 is 0.10 over 2 or 0.05. So z sub alpha over 2 is 1.65. Remember that in the first section of this chapter, we saw critical values for 90%, 95%, and 98%. Finally, we substitute in the formula. P hat minus z sub alpha over 2 times the square root of p hat times q hat over n is less than p hat plus z sub alpha over 2 times the square root of p hat times q hat over n. When we plug in these values and do the math, we get 21.1% is less than p is less than 24.9%. We can be 90% confident that the percentage of students who paid for their college education by student loans is between 21.1% and 24.9%. When a percentage is given, the percentage becomes p hat when changed to a decimal. So for example, a survey of 6,000 adults found that 58% would take a ride in a fully self-driving car. Find the 90% confidence interval of the true proportion. So p hat is thus 0.58, and q hat is 1 minus 0.58, which is 0.42. And z sub alpha over 2 is 1.65. Then p hat minus z sub alpha over 2 times, all that stuff. We plug all in the values again, and we get 57.0% is less than p is less than 59.1%. So we can say that the proportion falls in this range with a 90% confidence.